In this video, we're going to have a look at the field density workflow using the new aggregate soil sample type in QEST field. As soon as the new ASTM D6938 worksheet is made available in a laboratory, it will appear in the QEST field tests group as a workflow called New Nuclear Field Density. Adding this workflow will add the new aggregate soil sample and relevant worksheets. The data entry on these workflows will feel somewhat familiar to users of previous QEST field versions, but they will also have quite a different look as compared to the old sample type. The new aggregate soil sample itself is fairly simple. After some identification values and noting who created it, the sample contains some location details, including vertical location, which all field tests should have. In this case, we could use a depth test description or a numerical value for elevation, but we will use a lift to describe our vertical location. This is followed by material details, which we will leave blank because in this case they will be coming from our selected Proctor value. Finally, on the sample, we'll select a specification to get our limits and we move on to the actual test observations and details. We start with this Field Testing Details worksheet, which is a general worksheet that is added for all aggregate and soil field tests. By default, it captures weather and contractor. System administrators can define custom worksheets and use them in place of these defaults if additional information needs to be captured for all field tests. We then get to the Nuclear Field Density Test worksheet. We can mark this as a retest of a previously failed test, in which case we provide a date range of the failed test for the project and can select it from here. In this case, we're going to make this a brand new test. So the first thing we'll do is select a reference density sample. The reference density dropdown shows Proctor tests that have been completed in the laboratory and their results. It also includes this New Information button, which, when clicked, will show a dialog with details of the actual lab test, including any images attached to that worksheet. We'll go ahead and import these results. In the first part of the test, we select our nuclear density gauge. We can also choose to correct the sample based on the field oversize per ASTM D6718. Otherwise, we go ahead and enter some test data here and get a relative compaction and moisture variation value. This moisture variation is a little high, so we'll go ahead and up our field moisture a little bit since this is just a demo. And there is our first result. We can also access the test report from right here in the workflow. If I click on the report, it will open the report page, which will show me a preview of the data, but also allow me to view the PDF of the report directly in the browser. Very useful when a preview is desired. So we'll go back and I'll add a second point of field density testing to this work order. Just like with the previous version of QEST field, any common values from one sample to the next will copy across for me. So my general location is copied, and I only need to enter in my specific location, my material, and specification details are retained, as is my imported MDD test. So all I need to do is enter my wet density and moisture content values, and there we go. There's my second point of field density testing. I can sign this report here because I have the requisite user rights. Your technicians will not have this option if you do not allow them to sign field density test reports, but they can always preview that report as shown earlier. Additionally, these worksheets can have images added to them if we want to. We'll go ahead and select a photo to upload. And here we go. This photo will now be shown on the test report as well. We can go ahead and click Done and finalize this work order in order for it to show up in Report Review. And we're finished with field density testing in QP6.